Hi everyone, I'm Matt Podwysocki, known unoriginally on the internet as Matt Podwysocki. So if you find me on GitHub, on Twitter, I usually go by the same handle. I don't have a whole persona out there like anyone else. Anyways, today Michael actually gave a pretty good intro to streams and everything about streams. So basically, what I wanted to see is could we start this whole stream track with a general understanding of streams? Just kind of a survey here. Who here really understands Node.js streams? Oh, wow. Let's see. I have Isaac. I have Max, Michael. And somehow Substack is not raising his hand. Yeah, he doesn't quite get it. Gotcha. Anyways, so I think it's one of the most interesting pieces of Node. And as always, as you can see, when I think of streams, I always think of one of my favorite movies growing up in Ghostbusters. So heck, why not run with it a little bit? So let's go ahead and take a look at streams. After all, what does Node.js say on its website? It said building scalable network applications. How do you achieve some of the scalability? How are you able to abstract certain things? Streams, of course, help a lot of that, and in that you're building these pieces where you can abstract the I/O in such a way that you are really taking advantage of not having to buffer. You can do lots of other really cool things. And it's really awesome the way that the Node community has kind of gathered around this idea of streams. So let's just go into to Ghostbusters directly, because I just love this part of the movie when they're on their first gig. And something I forgot to tell you, don't cross the streams. Why? Because it would be bad. So it's kind of the misunderstanding about streams and how hard they are. And I'm fuzzy on the whole good, bad thing. And there is kind of the awesome quote, try to imagine all life as you know it stopping instantaneously and every molecule in your body exploding at the speed of light. Right, that's bad. Okay, all right, important safety tip. Now, I think instead what we should be talking about is cross the streams, because quite honestly, streams are awesome, and I think we can take a lot of advantage of them. But I think, once again, it's a little misunderstood. So once again, more quotes, why not? But this instead goes more at the idea of yes, let's do something really crazy and let's cross the streams. And with that is that we say, okay, cross the streams. You're endangering us. You're going to endanger our client, the nice lady who paid us in advance before she became a dog. Well, not necessarily. There's a definite slim chance we'll survive. And this line I love because it really explains my insanity for streams. Is I love this plan. I'm excited to be a part of it. Let's do this. So yeah, I work at a small company. You may have heard of us called Microsoft. And yeah, so my whole take is that I like to put the metal back in Microsoft. So anyways, I've been part of the Node community almost, I'd like to say almost since 2009, 2010, where I would literally crawl over broken glass and Sigwin to get Node.js working on Windows. And with that, I helped to work with, partner with Joyent, work on libuv and so forth, where we're able to help grow the Node community. And since that time, we've set up teams to work on Node on Windows and Node on Azure. And we've even actually released stuff which depends on Node, such as our Azure mobile stuff. And we're on GitHub, so we take pull requests, yada, yada, yada. I'm also the co-host of JSConf Live, a podcast with the aforementioned Chris Williams. We're kind of dormant right now, but hopefully with a lot of these great conversations we're having here, we'll really kickstart that thing again. And also, I work in a group called the Cloud Programmability Team, in which we actually focus our primary stuff on streams. Not necessarily node streams, but you think of SQL streaming, you think of Hadoop, you think of all those other things. Thinking about streams at scale, kind of Bing, Google kind of level. So I work on a project called Reactive Extensions for JavaScript. More on that later if you'd like to come talk to me and all that. So let's go to stroll down memory lane, shall we? Where did this whole idea of streams even come from? So a guy at Bell Labs, Doug McElroy, said in a memo in 1964, we should have some way of connecting programs like a garden hose, so that you could screw one segment into another when it becomes necessary to massage the data. For example, transforming it and then outputting it to something else. This is the way of I/O also. So this guy, Doug McElroy, if you don't know who he is best known for actually creating the idea of Unix streams and Unix pipelining. He was also very much a proponent of software components, so small reusable components. And he's an author of many of the things that you and I take for granted, such as diff, sort, join, graph, speak, and a bunch of other Unix tools. Now, his ideas were actually first implemented. It took a while. It took about 9 years for it to get implemented. But Ken Thompson in 1973 actually put it into Unix. And since that time, pretty much every operating system, almost, pretty much everyone, literally just took this kind of approach where you can take in a text file through cat, translate to take all uppercase and turn it into lowercase, and then output it to text. And Node, in its Unix philosophy that it had from the very beginning, also has taken this approach where we can say fs create read stream of an input, pipe it to what we'll call a quiet stream, which is a little through or transfer stream that I created, and then output it to out.txt. It's actually a pretty simple app, and we can take a look here. The quiet stream here, and if I actually put it on the right screen, I would be a genius. There we are. Here we are, where we have a quiet stream where we create a stream, set the readable and writable to true. We have an emit, which we'll get into a lot of these details a little bit later, but at the very bottom, we basically are just creating these reusable components, and then when we run it, here, it takes a capitalized Node Dublin and then turns it into a lowercase one. So pretty simple stuff, and yet super powerful. Now, if I could figure out, there we are, perfect. All right. So what and why? So what is exactly, what are streams? It's an abstraction of I/O. Like Michael was saying, it's a way for us to describe this idea of I/O, whether it comes from a file or whether it comes from a network, in one single kind of box, where we can start to reason about it all the same way. It shares the same shape. This is great because then pretty much anyone can implement this stream or take a shape of a stream and then be able to fully take part of the pipeline. It's also a way of thinking about incremental data over time. So the idea here is that you can deal with chunks of data as they come in instead of more of the async model, which is that you get an error and with the callback with the error and then the data. This more of a philosophy is you can deal with incremental data over time, and that allows you to have a lot more flexible design because now you can start doing more streaming algorithms. You can start really improving your latency, reducing your memory footprint because you're not taking that entire data and chunking it into memory each and every time. You're allowing yourself to hook into certain places, such as handling errors and so forth. without having to block, not necessarily block, but chunk and everything else. And that allows you to expand a lot of your possibilities and support more real-time behavior. So why use them? You know, this is a great example from Substack's Stream Handbook. So anyone familiar with the Stream Handbook? All right, good number of people. So it's a really awesome piece of literature about basically the philosophy of streams. Now, in this particular example here, what we have is we create a server here with our request and our response. Then we're reading a file. So right here, we're using the standard callback model where we have the error and the data. And then we check whether the error exists, and if it does, then we set it to 500 and end the stream. Else, we're just piping it on to the next. But once again, we're taking this data and then we're chunking it into memory when all we're really doing is just passing it through. But instead, if you take more of the Unix pipeline methodology, instead what we can use is create read stream, listen to the error, and then from there, you can pipe it along to something else. And now if you want to start adding on additional components, whether it's compression, whether it's encryption, etc., you can just start piping all of this in, and while having a pretty flexible programmatic model without you having to really dramatically alter your application all that much. It's just a part of the pipeline. So the stream itself is just a subclass of the event emitter. And what you do is you start to, as Michael rightly puts it, it's kind of a set of Legos where you can just start composing them together from a readable to a writable stream pretty easily through the pipe. Now, as I love to go into to more of these Ghostbusters things, let's just say this Twinkie represents a normal amount of power in Node.js. Using the power of streams, it would be a Twinkie 35 feet long and weighing approximately 600 pounds. Science, absolutely. And so for you Imperial Units challenged folks, that's 10.6 meters and about 272 kilograms. Needless to say, that's a whole lot of awesome. Kind of let's go over some grammar about what streams, what kinds of streams there are. So a readable stream, writable, transform, or through, and duplex. So a readable stream, basically kind of self-explanatory here, that what you have is you start to get your data through the data event when it's emitted, when you're emitting data through the data event, and then when you're finished, you can emit end. Ultimately, you can also emit error as well. In here, you also have things for pause and for resume. Don't really get too hung up on that right now, and we'll tell you why in a little bit. But in this particular case, all we're going to do is wait a second in between each one and emit a certain number of emit 0 through 4 here, and then end and clean it up. Writable, on the other hand, is very similar. It's the other side where you just set the writable to true, and you implement write, and optionally you can do destroy. You don't necessarily have to, but it's always a good idea to do so. In this particular example, we also, as others like Substacks point out, it's a good idea in end to handle any data that comes in as well, because there are a lot of modules in the core that do, such as response, which do take end, data and the end. This whole idea of back pressure, so everyone keeps saying when they talk about streams, they talk about back pressure. What is this mythical term, back pressure? And quite honestly, it's a pretty easy thing to remember, is it's making sure that the readable streams don't emit faster than the writables can consume. And once again, as I talk, you can take all of this with a grain of salt because it's changing, but at the same point, it's good to know a lot of the core fundamentals. When a writer from the right returns false, the reader pauses. When the writer is ready again, you emit drain, and then it's ready to resume via reader resume. So kind of here's a map of how that particularly works. When you emit data, it goes to write, emit end goes to end, pause and resume, emit, close, and so forth. Now, the idea behind the transform stream is that it's both a readable and writable. So what I showed earlier with our particular example of taking everything and lowercasing it, it was nothing more than a transform stream. So it takes the input and produces a result. Now, you could have any number of things. You could a transform stream could be buffering, it could be filtering data, transforming data, any number of aggregation and so forth. And these are really, really key for such things as encryption, compression, deserialization, side effects such as logging and so forth. It's pretty handy to know. And there are a lot of great modules out there, such as Dominic Tarr's through, which is kind of a toolkit for creating these kinds of streams. So you don't have to, what the great thing about the Node community is that a lot of these things are already modules, already out there on NPM. You can just start taking advantage of them. Duplex are both readable and writable. But how they differ from the transform streams is that it's more tightly coupled when you pause and resume, is that they're quite coupled to one another, whereas duplex, in this particular case, is more along the lines that they have their own states with pause and resume. Not super important, but what you really see here is that when you see a pattern such as stream 1, pipe to stream 2, back to stream 1, sort of like a telephone, I'm calling you, I reach the other side, sending data back to me. That's kind of how duplex streams work. And now when you think of things like TCP, HTTP, or even data replication, it kind of follows this very same pattern. In Node Core, ton of built-in ones, whether it's process, net, HTTP, FS, etc. Also, like I said, there's the awesomeness around the stream community, such as Michael's requests and file. You have JSON stream, the ability to query and transform JSON is really neat. Mux to Mux, Shoe, pause stream. Pause stream is very interesting in that since data is fired rather eagerly, whether you've got a listener on the other end, could cause a number of problems of kind of race conditions. So a pause stream, the idea is that you can say freeze it in time, and then when you're ready to go, you're ready to go. Emit stream goes back and forth to event emitters, through scuttlebutt, really cool stuff about the gossip, an implementation of the gossip protocol, which is basically peer networks that are eventually consistent. Really cool stuff. tar, dnode, event stream, kind of a toolkit that Dominic had been working on. Really great community around here. Obviously, there are a lot of people. This is obviously not exclusive, but check those people out. They have a lot to say about it. Now, what I was talking about is that things are changing or will have to change in some form or fashion. One of those things was that the data is eagerly fired whether you're ready or not. Also, that you have to implement a bit of plumbing yourself. For example, pause and resume. It's not always self-explanatory how you do that, especially if you're not part of the core. And also that the contract of pause and resume and all of that, where you're not firing data while it's paused, also has issues because it's the contract itself is not thoroughly enforced. So what does that bring us? Well, obviously, fire and brimstone coming down from the skies, 40 years of darkness, earthquakes, volcanoes, death, the dead rising from the graves, human sacrifice, dogs and cats living together, mass hysteria, obviously. So some of those changes, one of the fundamental changes is this idea of the new readable class, which takes care of a lot of the pause and resume for you. So you don't really have to worry about that anymore. Instead, what it's doing is adding a new kind of flow model to it. which is kind of described down here, where you can iterate on calling the read method, which keeps on returning you data until it hits null. And so you can continue to process it. And then once it returns null, that's when you know it's ready to start again, that you're going to read again. So the next time it has some data buffered up, you're ready to go. Isaac has this out there on GitHub, so you can take a look at it now. He also has some really other interesting stuff of the transform stream, duplex, and a few other things. It's really worth reading, especially if you're going to start getting into streams now. The aforementioned streamed handbook, very, very useful if you're going to get started in streams. Also, if you really want to understand some of the basic concepts in terms of how streams should react, Dominic Tarr's spec stream, also very, very good. And with that, thank you.